Good evening, guys. Welcome again to Knowledge is Power. And thank you for checking out my channel. I appreciate it. This video, I'm going to share with you the probability secret of quantum math. And I'm going to share with you the Monty Hall problem. And I know you've seen these videos, or you've probably seen these videos before, but I'm going to urge you to uh, do this experiment for yourself. Okay, follow along with it, and then actually take three pieces of paper and actually go through the motions. Because when you do that, something's gonna ignite within you, and then it'll stay with you forever. But here's how it works. Okay, it's a counterintuitive way of thinking, but it's 100% accurate. Okay, so I repeat that. This is 100% accurate. The theory goes like this. There are three doors, and behind two of the doors is the not prize, okay? Not what you want to get. Behind the third door is the prize that you want, okay? Now you're told to pick a door at random. So, what we're going to do to test this and simulate a random draw is we're going to just leave the answers like this, and we are going to rotate between selecting this one, and then the next time we're going to select this one, and then the next time we're going to select this one, and we're going to go back and forth 10 times. Okay. Now, what happens is you're told to select a door at random. So we're going to start out by selecting this one. When we select this one, we have a 33% chance of being correct at our guess. 33.33, but I'm going to round for easy math. Now, after we make the selection, the host of the show, because this is called the Monty Hall problem, the host of the show will remove a door that has the wrong answer. And now they say to you, all right, now would you like to keep the door that you originally chose, or would you like to switch doors for a chance to win the prize? And what most people think is that they have a 50-50 chance of getting this correct. However, the fact is that they only have a 33% chance of getting it right. And if they switch to the other door, they will be correct almost 7 out of 10 times. So just the simple act of changing your answer, changing your selection, doubles your probability of getting it right. Now, I know what you're thinking, and I know you think it's bullshit, but I'm going to show you that it isn't, and I encourage you to do this test on your own so that you can see and make it resonate with you. And I'm also going to show you the theory behind it, because I've been thinking a lot about how this applies to our lives. So here's what happens, okay? In the first example, we picked this one in the first place, and we're going to be wrong 2 out of 3 times, all right, or correct 1 out of 3. When the host removes one of the wrong answers, what happens is now you have to think the opposite. You have to think the inverted way of what you would normally think. If you are going to be wrong 2 out of 3 times, and the host removes one of the losing doors, that means that the other choice, the one that you didn't choose, is going to be right 2 out of 3 times. So the correct play is to change to always switch your answer. Okay, and we're going to go through this 10 times just so you can see. So we're going to consider this the first try, okay? And the first try was we selected the far left, and then the judge removed the second door. And when given the opportunity, we switched. So we were correct 1 time out of 1 time. Now we're going to do this again. Only this time we are going to select the second door. And now the judge is going to remove the wrong answer, or one of the wrong answers, and we are going to switch. Okay, so now we're right 2 out of 2. Now we're going to do it again. On the try number 3, we're going to select the far right door. The judge is going to remove one of the wrong answers and then give us the opportunity to keep our original pick or switch. And we are going to switch. That makes us wrong. So now we've done this 3 times. We were correct the first 2 and wrong the third. So we're going to continue. 3 choices. We select at random the far left. The judge then removes one of the wrong options and gives us the opportunity to keep our choice or switch. And we switch and are correct. So now that is 3 out of 4 tries, and you can see already. As a matter of fact, I'm not going to keep doing this, but you can see already that you're going to be right 2 times out of every 3, and if you do it 10 times, you're going to be right 66.66% of the time. Now, if we go the other way and we don't switch, you're going to see that you will be wrong. You're only going to be right 33% of the time. So now, if you want to know why it works that way, you have to invert your way of thinking, and that's why that it's important in this existence is everything is backwards. Everything that means anything that's significant for you to use in this experience, you have to think inverted. You have to think backwards. So here's the concept that hopefully will make it make sense to you, because this is how it ended up making sense to me. All right, so it helped me when I scaled it up, okay? And what happens is once you're able to think on the other side, it gets really easy to figure this out. But at first you look at it, and at the very best you might say like, oh yeah, okay, I believe it, but I'm not going to worry about it. And that's detrimental, because when you invert your thinking, okay, when you learn to think on the other side, there is this whole other world right in front of you. And this is the way to properly use your words as spells. Okay, this plays into the English language even, with David Wynn Miller's stuff and syntax grammar, and that most of the words in the English language are actually negated words. So if it starts with a vowel followed by 2 consonants, every single word in the English language that starts with a vowel and 2 consonants is not a word. It's a negated word. And that is the problem with spell casting. And if you've heard stay in the now, what it means is keep your speaking in the present tense, and that's where you will be. So just so watch this, okay? There are 9 choices here, and only one of them is correct. All right, it will be easier mathematically if I add one more, so that's what I'm going to do. Okay, so now we've got 10 options here. There are 9 no's and 1 yes. Okay, so what's happening is when you pick any one of these, when you pick at random, you're only going to be right 10% of the time. So if we pick, say, this one, okay, the top left, what's happening is that we're basically, we look at it as if, we're going to be right 1 out of 10. And then the judge is going to eliminate all of the other answers except for 1, okay? And then they're going to give you the same choice to switch. So when you look at it that way, what's happening is that you are going to be wrong 90% of the time when you make this selection. And if the judge eliminates 8 of the other answers, leaving you between your choice and another choice, and then says, hey, do you want to switch or do you want to keep your original choice? What's happening is that you're not at 50-50 like you think. You're not at the place where, now, oh wow, there's 2 doors left, and you picked one and there's another. So, what do? Stick with your gut instinct? No, it's stupid to do that because you are going to be wrong. You're going to be wrong 9 out of 10 tries. Whereas if you switch, right? If you switch to the other door that's remaining, you are going to be right 9 out of 10 tries. Okay, so just like this one, you pick this one, and the judge closes all the doors, leaves you a choice. You switch, and when you switch, you now switch to the winning choice. All right, and if we do it again, and we just randomly go along this list, if you originally select option number 2, and then the judge eliminates 8 of the doors and gives you an option to keep yours and or switch, you see that it's always the right play to switch. And I doing it this way, it kind of makes it a lot easier to see how the probabilities work, because if we switched from the original choice in the first example, we're going to win. If we switch from the choice in this example, we're going to win. And if we keep going, if we start out picking this one, and then all of them are eliminated except one door, we switch, we're going to win. If we pick this one, we switch, we're going to win. The only time we're going to lose if we switch is if we picked the right answer on the first try, which is only going to take place 1 out of 10 times. So that is like one of the secrets to this existence. Okay, and I know that this is important because I first saw it on the movie 21, which made me think that there was something up with the math that we were taught. Then a subscriber and friend sent me a link like a week ago maybe, about the Monty Hall problem, which made me look at it again. Only this time when I looked at it, I actually sat down and I did the experiment. And it's amazing. As soon as you do this for yourself, it's like your mind just goes, whoa, there is something here that I didn't know about. And what it is looking at the inverted side of things. So the reason that this plays an important part, first of all, it'll play a part in your Powerball lottery efforts. When you look into quantum mathematics, you'll see that there is a very, very, um, very like a, I'm struggling to find the right word, um, but it is a routine system that's followed. So if you flip a coin 100 times, chances are it's going to be heads 50% of the time and tails 50% of the time. But if you're flipping the coin and you're in a position where it's been heads only 10% of the time and tails 90% of the time, what's going to happen is it's going to start turning up heads a lot more often, so that it will balance the bell curve. So that's kind of the way that this math works in our existence. And if you look into quantum math and vortex math and higher math, that's when you kind of start to learn that you were ripped off in high school or even college. And now when you tie that into our language and the fact that what we speak becomes via spells, right? Spelling, the English language, it's because the words that were taught to us have multiple different meanings. Any word, even numbers, the number 2, it could mean also. It can mean the number 2. The number 4, is it for me? Is it for you? Is it for on the golf course? Or is it for the number? Um, same thing with the number 8, right? Is it the number 8, or we ate dinner? And I know those are simple examples, but what happens is the language itself was constructed in a way called Babel, just like in the Bible. When the Tower of Babel was built and destroyed, the people were given different languages. That's what this is talking about, is how we all interpret things differently, and we think that our message is being heard and interpreted properly, but in reality, we have absolutely no way of knowing that the other person truly understands what we're saying. So the fact that the English language is a bunch of spells, and the words that we've been using are negated words. Resign, resigned, decline. Any words that have the prefix un, de, um, you know, any of that. It doesn't mean what we've been taught that it means. It means that it's not a word. It's a negation of the word, meaning the word isn't even there. It's a fiction, and what it's all meant to do is to get us out of the now, get us out of the moment. So I hope that this has helped you understand that there's something going on with the math, and that this is how, okay, this is how the universe works. It's all about probabilities. It's a computer program. So by understanding the probabilities, uh, this is going to open up a big time door for you. And when you tie it into the language and stop using words that have multiple different meanings, and you stop using words that don't really mean anything or that mean the opposite of what you think, that's when your manifestation is going to take charge and take hold properly. That's when everything is really going to happen for you. And I watched a video actually several videos by Wynn Miller, and the idea there is there are millions of words in the English language, and only 720 of them are actually used that can be used in the proper quantum syntax grammar. So it's amazing stuff. I urge you to look into it if you haven't already. And for now, though, check out the probabilities, and I hope this has helped you kind of understand the Monty Hall problem. Thanks again for listening. I appreciate it. And if you guys have anything that you want to that you'd like me to talk about or do a video on, let me know and I'll be happy to do so. So thanks again. Take care.